Alright, today's lesson is about finding volumes of prisms and cylinders. So first off, we got to talk about volume, what it is, and compare it to surface area. In the past, surface area I talked about being like wrapping paper. So how much wrapping paper does it take to go around the 3D shape? Volume is how many cubic units fit inside the shape. So if you had a bunch of these little cubes, how many of these cubes could you stack inside the shape? So how much inside the shape? That's the key word, inside. Key thing on units, surface area is a type of area, and area is always units squared. Volume is going to be units cubed, hence the word cubic. So the first shape we can talk about is the volume of a cube, and its formula is really easy. It's just side cube. For this little postulate, it's pretty straightforward. The volume of a solid, if two polyhedra are congruent, then they have the same area. Same volume. On postulate 29, it says the volume of a solid is the sum of the volumes of its non-overlapping parts. So what that's indicating is if you have some shapes kind of stacked on each other, like this, if you have a triangular prism on top of this rectangular prism, then you can find the volume of one and add it to the volume of the other. You don't have to subtract out anything like we did on surface area. The next shape is volume of a prism. Its formula is big B times H. Big B, once again, it tells you big B is the area of the base. So it's not just one dimension on the base. It means the area of this whole shape that we're going to be outlining. And I once again encourage you to outline that base. That's the shape we got to find the area of for big B. Volume of a cylinder is similar. Instead of doing big B though, we know the area of its base. It's pi r squared and then times the height. So pi r squared times h. Now we have some examples. The first shape is a right triangular prism. What is the shape of its base? It is not a rectangle. That's a common misconception. It is named by its base. So what's the shape of its base? Triangular prism. So a common thing that I have seen over the years is people see whatever's on the bottom and they call that the base. However, when we define the word base, I said it's not always on the bottom. In this case, when it's a prism, you should be able to find these two congruent shapes that are parallel. Those are the bases. If you said rectangle, it should have another rectangle up here, parallel and congruent, but it doesn't. Therefore, it cannot be a rectangular prism. That's definitely a triangular prism, especially since it said it. So that means for the big B, I got to find the area of that triangle. How to find the area of that triangle? Yeah, I heard it. 1/2 times the base times the height. What numbers do I plug in for base and height on that triangle? Yeah, 1 and 3. Those are the numbers that meet at the right angle. That was the critical thing we've learned in the past, the numbers that meet at the right angle. So 1/2 times 3 is going to be 1.5. We also need its height. What's the height of that shape? Okay, so it is 2. A common misconception is 1. Because it's vertical, people think that's automatically the height. But we define height as the distance that the bases are stretched from each other. So it's stretched out 2 feet from one base to the other. Now I can do my formula. Volume equals big B, which is 1.5, times my height. So our volume is 3 feet cubed. Now cylinders I think are much easier. I'll do the cylinder over here. It's a right cylinder. That means the angle that the side makes with the base is a right angle. So it's kind of hard to see from this view, but that's going to make a little right angle right there. So once again, we've already discussed its formula. Pi r squared h. I need r, I need an h. Do we know its radius? It's 5. Square it, then times the height. 6. So this one's pretty straightforward. We're going to get a decimal answer here. What's the decimal final answer? 471.24, and make sure your units are on it, meters cubed. Example 2 is definitely more challenging because in that formula we're not given a radius. We do remember that the volume formula is pi r squared times h, but they give us a volume here. We're going to plug that in for v. 1253 equals pi. Do we know our radius this time? No, it's x. We have to square that radius term and then times by the height. So our goal here is going to be to solve for x. So this is now algebra. We got to figure out how to isolate x, how to get x alone. How do we do that? What do we get rid of? The pi and the 10. Since this is all multiplication, that means I can divide by both of these terms I'm trying to get rid of. I'm going to divide by 10 pi, 10 and pi. I'm going to do that on each side, and I did put it in parentheses. It just makes it easier. It's a kind of a little group of two terms you've multiplied together. So on your calculator, you should be able to do 1,253 divided by 10 pi. I'll give you a second to do that. All right, we get 39.88 equals x squared, but we're trying to get x alone. I don't want the square with it. How do I get rid of the square term? Square root each side. And x is going to be 6.32. And the units are centimeters. All right, this little principle up next is kind of interesting. It says if two solids have the same height and the same cross-sectional area at every level, then they have the same volume. And I'll show you what that means. If we have two cylinders, and they have the same height, that means their base starts the same spot and their height goes to the same spot. This is the height of this piece, and this is actually the height of this piece. Remember, height is always going to be our perpendicular distance. This piece would be our slant height. Do they have the same height? Yes. They have the same base, and they have the same height, therefore they're going to have the same volume. The cross-sectional term means if you take a cross-section here, and they're the same, then all the others are going to be the same as well. So those two shapes are actually going to have the same volume, even though one is leaning to the side. So now we're ready to do this one. Remember, it's the same formula on example 3. We still do volume equals pi r squared h. So let's write that out real quick. Volume equals pi r squared times h. Do we know the radius? Yes, it's 5. Do we know its height? Its regular height? Straight up? Yes, it's 8. So if we type that in, we'll get our volume, which is 628.32 inches squared. Sorry, I meant inches cubed. I misspoke. Inches cubed. Volume is always cubed. Thank you. Example 4 has a cylinder and then another cylinder drilled out of it. So that's like a hole over there. This little portion right here is cut out of that main cylinder. So whenever we take a big and a small, we're usually going to subtract them. That's exactly what we're going to do. We're going to find the volume of the big shape and subtract the volume of the small shape. So let's find the volume of the big first. So on that big shape, we're going to do pi r squared times h. So our r is 3 and our height is 7. For our small shape, we're going to do pi r squared h again. And what's the radius on that small one? I think it's 1. And its height is going to be the same. Type these in real quick and give me the decimals. You could actually type this straight in. You could do this value, subtract this value, and you'll go directly to the answer. All right, so once we subtract this value from this value, this value from this value, we get a total of about 175.91, and the units are millimeters cubed. So there would be our final answer on that problem once the cylinder is drilled out. On this first one, we have a right rectangular prism. So on that one, we learned our volume formula is volume equals big B times H. So we need to find our big B and our H. Our big B is the area of the base. In this case, I would say it's the bottom. Not always, but it is in this case. So 4 times 11 is 44. The height is the vertical piece in this case. That's my opinion. So 5 times 44, that's what we need to do on our calculator. 44 times 5 is what? 220 meters cubed. The next one up is a right cylinder. Its formula is volume equals pi r squared times h. So this is pretty straightforward. It gives you your radius and it gives you your height. You type this straight in and you get your decimal answer. What do you get there? 101 point, what? 1017.88 feet cubed. This next one's a little tricky. You start off with your volume formula, and then you substitute what you know. We know the volume is 200 times pi. Do we know the radius? Nope. I'm not going to call it x, because x is actually the diameter in this case. I'm going to call it something else. I'll call it r for radius. Now, the other piece is the height, which is 8. We talked about it earlier. If you're trying to get a variable alone, you can divide by the pi and the 8 at the same time. Just make sure to do it with parentheses. Now, this is pretty straightforward. Pi divides with pi. 200 divided by 8 is 25. And what squared is 25? You should know that is 5. Well, if the radius is 5, you have 2 of them up here in this picture. 5 plus 5 is 10 centimeters. On this next example, we have an oblique cylinder. That means it's leaning to the side. Whenever we have an oblique shape, that means it's leaning. So it still has the same formula as a regular cylinder. That's volume equals pi r squared times h. Now we've got to look down here at this figure and see what do we know out of that figure. Our h is actually over here. We don't want our slant height for our h, so there are 2 different terms. However, we do know our radius. Our radius is what in this picture? It's half of 12, which is 6. Good. The other piece we got to find is our height. To do that, we need to focus on this triangle right here. So whenever we have an angle, we typically like to think of special right triangles or trig. In this case, I'm going to encourage you to try trig because it's on more problems on our ACT. So for trig, we need opposite, adjacent, hypotenuse, stuff like that. So this piece across from the 60 is called our opposite side. And this piece right here can be shifted over to right there. And in a right triangle, this is called our hypotenuse. So which trig ratio deals with opposite and hypotenuse? It's actually sine. So I'm going to write that up here, sine. We always do sine of an angle equals its ratio. That's opposite over hypotenuse. So opposite in this case is h, our height, and our hypotenuse is 18. We're going to cross multiply here. So h times 1 is just h. Now try to type in sine of 60 times 18 and see what you get. Alright, so I heard we get 15.58. That's the height that goes in. Now we're ready to type in our volume. So we do volume equals pi times, our radius is 6, square it, times 15.58 to get our total volume. Let's see what that is. 0.05, and we always put our units on volume, so that's millimeters cubed. It might be 0.06 here is what I just heard. On this next shape, we have two different shapes stuck together. This one on the top is actually a half cylinder. This one on the bottom is actually a cube. So I need my cylinder formula first. That's volume equals pi r squared h. But I just talked about, this isn't a full cylinder, it's a half cylinder. So I'm going to take that and divide by 2. For our cube, it's a very simple formula. We do side cubed. So let's do our half cylinder first. We need our radius, and the radius goes from here up to here. You can think of it also as rotated around to right here. That distance can be transferred down. That's half of 4, or just 2. So that radius is 2. The height, be careful, is actually this distance stretched back. How far is that cylinder stretched? And you can see that transfers to 4. And now we can plug this into our formula and get our volume for our half cylinder. Alright, so this first one we get a volume of 25.13. The second one we're going to plug in our side length cubed, and down here on our cube it's 4 cubed. 4 times 4 times 4 is 64. Once again, when we're having two solids and they're composite, that means we're going to add them together. So 25.13 plus 6.14 is going to be 89.13 inches cubed. That's our total. We got that by doing 25.13 plus 64.